Hey, this is Math 6, Unit 4, Lesson 3, Interpreting Division Situations. So you first of all begin with a little dot image here on properties of multiplication. And so you have this quick image. Your teacher probably flashes up on the screen for you quick and wants you to figure out how many dots are in that image and then kind of think of what you might visually see that there. There's lots of ways you might go about kind of figuring this out. I noticed that here you have groups of 4 essentially. These are all groups of 4. And so when I double 4, I actually have groups of 8 realistically. So I saw this as a group of 8. And I noticed that I had like a die. I have like 5 of these here, but really 4 with the extra one there. So I have 4 and I have 4 here. And then these two are also 4, which becomes another group. So I noticed that I have groups of 8. I end up with 9 groups of 8 for a total of 72 without having to count those up there. There's other ways you might visually have seen that, and that's great. It's something for you guys to talk about in your class and kind of what do you see and how do you figure that out. Let's take a look today at the homemade jams first of all, as we can learn to interpret division situations. It says draw a diagram and write a multiplication equation to represent each of the situations. All right, then answer the question. So it says that May had 4 jars. Great. In each jar, she put 2 1/4 cups of homemade blueberry jam. Altogether, how many cups of jam are in the jars? Okay, so if we think about it like this, here's May, and May's going to have 4 jars. So we take a little tape diagram like this, and we draw 4 sections here for 4 jars. 1, 2, 3, 4 jars. All right. We know that she puts 2 1/4 cup of jelly or jam in each one, 2 1/4. And so the question really is that how much jam is there in all? That's what we don't know. We know that there are 4 jars, right? This is my jars, and this is my jelly, and this is my total right here that I don't know. As a multiplication problem, what we're talking about here is that we know we're going to take the 4 groups of 2 1/4 to find out how much there is in all. Okay, that's the idea there. So 4 times what is going to get you, 4 times 2 1/4 is going to tell you how many cups there are in all. Even without doing a calculator kind of thing, I know that 4 times 2 is going to be an 8, and then I know 4 times 1/4 is 4 over 4, which is 1. So in all, I'm going to have 9 cups of jam is how much there would be all together as a solution there if I had to actually answer that out. Okay, but that's the way I would draw a diagram to show that there. That's a different diagram than what I would do here, number 2. Because the 2 says that Priya filled 5 jars using a total of 7 1/2 cups of jam. So in this case here, we take our tape diagram, and instead of 4, we're going to have 5. So 1, 2, 3, 4, 5, right? So we have 5 jars. Those are my jars here. And we know she has a total of 7 1/2 cups. So if I take this apart, I know that my whole thing is 7 1/2 cups. What I don't know is how much is in each one of these jars, right? So what we have in this case here is we know that she has 5 jars and she has some amount in them, and in total it's going to be 7 1/2, right? That's what she's talking about in that point there. So she has 5 jars times some amount inside of each of those for a total of 7 1/2 cups. And that's how that one works out there. In terms of a solution to figure that out, what we're doing is we're taking 7 1/2 and what are we doing? We're distributing it, we're dividing it into 5 different groups. So another way of thinking about this is saying that we have 7 1/2 cups of jam, and we're going to divide that into the 5 jars. So to rewrite this, it becomes 2 times 7 is 14, plus 1 is 15 over 2. And then 15 over 2 divided by 5 is what we're working on there. And 15 over 2 divided by 5 becomes 15 divided by 2. And we multiply by the reciprocal here. And we're going to borrow, or we're going to reduce, and we end up with 3 over 2, or 1.5 cups is what would be in each one of those. Okay, let's look at number 3, because 3 again is another way of looking at it. So far we've had our question mark be the total, our question mark be how much is in each. This says had some jars. What we don't know is the jar number. It says he put 3/4 of a cup of grape jam in each jar for a total of 6 3/4 cups. So what we know here is that we have some jars, right? So we have a jar here, and we have a jar here. And we know that in total we have 6 3/4 cups, right? We know that in each jar is 3/4 of a cup, so I'm going to put a 3/4 and a 3/4, and then in here I don't know how many more of these I might have, so I'm going to just indicate that with a question mark. So we know that in terms of the jars number is what I don't know. How many might there be if I'm going to put 3/4 of a cup in each one of them? So what we're saying here is I'm going to have, I don't know how many groups of 3/4 will equal 6 3/4. That's what I don't know. So it's hard to draw that. I'm just drawing a bunch of question marks here in my little tape diagram to indicate that I don't know how many groups I'm going to have there. So as a multiplication problem, we write it like this, but I can actually solve it as a division problem again by saying, well, I'm going to take the 6 3/4 and I'm going to divide that into 3/4 quantities, right, for each one of the jars, and that will tell me how many of them I can actually make. So this becomes, divided by. So this becomes 24, 25 to 27 over 4. We multiply by the reciprocal. The 4's cancel out. 3 goes into 27 9 times, and we end up with 9 being the number of jars I could actually do that with. So it works out okay, and we can see how that we can turn a multiplication problem into a division problem, because that is what we're talking about here, dividing that whole amount up. But that from a visual standpoint, we end up with 3 different diagrams showing the different ways this can be illustrated. Either we're missing the total, we're missing the amount that goes in the jar, or we're missing the number of jars there. Okay, so great problems, and this is kind of a good little base for you for moving forward. Let's look at the next activity. Alright, making granola. To make 1 batch of granola, Kieran needs 26 ounces of oats. Okay, so we need 26 ounces of oats for 1 batch. The only measuring tool he has is a 4-ounce scoop. So how many scoops will it take to make to measure 26 ounces of oats? Will the answer be more than 1 or less than 1? Okay, well, first of all, it's a scoop of 4 ounces, right? So we have to go from 4 plus another 4 and keep doing that until we get to 26, right? So it's definitely going to be more than 1 scoop, right? Because 1 scoop is only going to get me to 4. I need more than that. Write a multiplication equation and a division equation that represents a situation, and use question mark to represent the unknown quantity. So I have a 4-ounce scoop times how many of those to get me to 26. That's what we're talking about here. I use the 4-ounce how many times to get to 26. So as a multiplication problem, I have that. As a division problem, I would have 26 divided by 4 will also tell me how many scoops I would need. Okay, so in this case here, if we want to draw like a picture there, we could do that, or we could figure this out here. So in our case, we can do 26 divided by 4, and think of it like, I don't know how you want to think about it, but 26 divided by 4 is going to give us, well, yeah, 4 times what number gets 26? Let's think about it this way. 4 times what number gets you 26? I know that 4 times 6 can get me to 24, right? So 6 scoops gets me almost there, but I need another 2 ounces, right? And if a scoop is going to be 4 ounces, I want half of that, so half of that, and so I want half of a scoop, right? I don't want a whole scoop, I want half of a scoop, which is going to be 2 more ounces. So what I want is I want 6 scoops and a half a scoop. So combined, I want 6.5 scoops in order to get to 26 ounces. All right? If you think about 26 divided by 4, 4 goes into 26. We would say it goes in there 6 times, 24. We subtract and we have a 2 there. We bring down a 0. 4 goes into 25 times, so we have 6.5 as a decimal answer. That's the same as 6.5. All right, and that works out okay. All right, that's the idea. Again, as a diagram, you might think of it this way, right? Here's a scoop, that's 4. Here's another scoop is 4. Another scoop is 4, so now I'm at 12. Here's 16. Here's 20. Here's 24. If I do a whole other scoop, then I'm at 28. I don't want to be at 28. I just want half of that scoop there is all I want. So that's where I end up with that 6.5. Number 2. The recipe calls for 14 ounces of mixed nuts. Okay. To get that amount, Kieran uses 4 bags of mixed nuts. All right. Well, I had a mathematical question that might be asked about this situation. So they're going to use 4 bags. It needs 14 ounces. Okay. So how many? What we don't know is how many ounces of mixed nuts are in each bag. That's what we don't know. Because she's taking the 14 and dividing it into 4 bags, and the question mark is going to be what we want to find out is the how many ounces are in each bag. That's what we're going to find out by doing that there. So to find the quotient, 14 divided by 4, again, let's just start with the basic part, right? Just to help you out. What we're saying is doing 14 divided by 4 is doing this, right? 4 goes into 14, we know 3 times 12, we end up with 2, bring down the 0, it goes into 3.5. So we know we're going to have 3.5 as a solution. Don't worry about that for now, just kind of mentally know, I know you can do it. What are we talking about now? We're talking about having 14, right? So here's our 14 here. And we're going to take the 14 and we're going to use 4 bags. So 1, 2, 3, 4. Those are our 4 bags. And we're trying to figure out how much goes into each bag. That's what this means. 14 divided by 4 equals question mark. So that's our diagram there, what that looks like. So if you thought about a bag like this, here's a 1 bag and 2 bag and 3 and 4. And I have 14 to put in there. I'm going to just do that evenly to kind of figure this out, right? So I do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and I have 13, 14. I have 2 left over. I don't just throw them away. I need to share them, right? So I'm not going to put a whole 1 in each of them. I'm going to do 3 and what? I'm going to break those into halves. So that's how you end up with 3.5 if you need to kind of visually see how is that working out there. So each one of these becomes 3.5. So 3.5. All right, does that make sense a little bit there? Hope that does a bit. All right, and that's what you get. Okay, so as a summary today, it says if a situation involves equal size groups, it's helpful to make sense of it in terms of the number of groups, the size of each group, and the total amount. Here are 3 examples. So we showed this here when in our activities there, right? So suppose we have 3 water bottles, 3 bottles, 6.5 ounces. What's the total amount? So that's the 3 bottles, 1, 2, 3, and they each have that much. And what's the total amount? That's what's unknown here. So the multiplication is 3 times 6.5. We would get our solution. Down here, let's say we have 20 ounces of water that needs to go into 6 equal size bottles. So we're doing 20 divided by 6 here, right? We're going to divide it into 6 groups. 1, 2, 3, 4, 5, 6. What we don't know is how many ounces would be in each of those bottles, and that's what we'd be figuring out. As a multiplication problem, it's 6 times something equals 20, right? Or as divisions, 20 divided by 6. And then our last way of setting it up here is sometimes we don't know how much is going to be in each group. So sometimes we know that we have 40 ounces total, and we're going to pour it into bottles, and 12 ounces go in each bottle. So that what we don't know is how many groups we're going to have. 1, 2, 3, 4. We don't have any idea. This becomes our question mark for how many groups we're going to have. And that's okay. So that still is something times 12. This something times 12 is going to equal 40. But what's that going to be? We don't know. Okay? So whenever we have a multiplication situation, one factor tells us how many groups there are, and the other factor tells us how much is in each group. Those are the two factors we're talking about. So how many groups there are and how much is in each group is what we're talking about when we're dealing with multiplication situations. Okay? Sometimes you want to find a total, sometimes you want to find how many groups, and sometimes how many are in each group. It just depends on the situation. All right, we're going to pause there, let you work on your homework, and we'll come back together in just a moment. All right, homework time. It says write a multiplication equation and a division equation that this diagram could represent. So we have 54 of something in total, and we can see that there are going to be 3 groups of them, and each group has 18 inside of it. So as a multiplication problem, we could say what we do. Well, we could say that we have 18 times 3 equals 54. We could say 3 times 18 equals 54. In terms of division, we could say 54 divided by 3 equals 18, sorry, and 54 divided by 18 equals 3. Any of those are going to be just fine. Number 2, May has $36 to spend on movie tickets. Each ticket costs $4.50. How many tickets can she buy? Write a multiplication and division equation. So she knows that she has $4.50, and she wants to know how many tickets she can buy, and she will have a total of $36 spent. Or we can think about it like this. It's $36 divided by a price of each ticket will tell her how many tickets she might be able to purchase. Either one works. They both will get you the same answer. So let's find the answer. So 36 divided by 4.5, or 4.5 times something I don't know. Again, as a picture here, here's a picture. So you have 36 of something, right? So that's what we have, 36 of something. We know that every time she buys a ticket, it's $4.50. $4.50. What we don't know is how many tickets that actually will be, right? That's the part we don't know. We know the value of each one of these is $4.50, the value of each box. We just don't know how many boxes are going to be. So to solve this here, you do $4.50 times some number is going to get you 36. I thought about it this way. I did $4.50 in my head times 2 gets me to 9. 9 times 4 can get me to 36, which is my total there. So in all, I have 4 times 2, which is going to be 8, which tells me that 8 is going to be my solution. I can see if that's right by doing $4.50 times 8. Let's say $4.50 was the ticket price times 8 tickets. Multiply that out, we end up with 40, 4, 32, 36, and sure enough, it works okay. So 8 tickets is how many she could buy. Curran said that this diagram can show the solution is 16 divided by 8 or 16 divided by 2 equals something, depending on how we think about the equations and the question mark. Explain or show that Kieran is correct. Okay, so if it's 16 divided by 8 equals question mark, then the question mark is going to stand for, in this case here, how many groups. This is asking the question of how many groups of 8 are in 16. So if I take 16 and the size of the group is 8, how many groups am I going to have? That's the question mark, question mark, question mark. Okay? If you did 16 divided by 2 equals 8, then the question here is going to be, okay, how much is in each group if 16 is divided by 2? That's the question there. Okay, so yes, they're both correct. Just depends on how you want to interpret those numbers and the question mark. All right, Number 4, write a sentence describing a situation that could be represented by the equation 4 divided by 1 1/3. So this is something you have to be creative about. So you might say something like 4 cups of sugar are available and the recipe calls for 1 1/3 cups. So how many batches of the recipe can be made? Okay, so think about having a large quantity of something and you're going to break it up into 1 1/3 chunks of something else. So how many times could you do that? How many times could you divide 4 by 1 1/3? Okay, I'll leave that there and you can write your own answer in there. 5, when you divide a number by, Noah said when you divide a number by a second number, the result will always be smaller than the first number. Jada said, I think the result can be larger or smaller depending on the numbers. Do you agree with Noah or Jada? Well, based on what we saw last time, we would probably go with Jada, right? And what we saw was that when you take a number like, we used 4 last time, right? We did 4 divided by 40, and we did 4 divided by 2 as our examples before. So when you divide a number by a second number, the result will always be smaller. Well, 4 divided by 40, that's smaller, that's 1/10. That's smaller, sure. We do 4 divided by 2, then the answer here is going to be 2. Now he says always be smaller than the first number. In this case, yeah, they're both smaller than the first number. That's true, but is it always true? What if our number was, I don't know, let's go with something else like a 2 or a 1. It's not always going to be smaller. It's just that if you divide by a larger number, it's going to be less than 1. Okay, and this will be more than 1. So you'd have to take a number like 1 and divide it by something smaller to make that work, right? So if you did 1 divided by a half, for example, now we have something that's a little bit different, right? 1 divided by a half is actually equal to 2. So in that case there, the answer is actually larger than the first number there. So it doesn't work once you start, his idea doesn't work once you start playing with fractions and dividing a number by a fraction. It just isn't going to work out. All right, let's take a look at number 6. All right, mini muffins. Mini muffins cost $3 per dozen. Andre says, I have $2, so I can afford 8. Elena says, I want to get 16 muffins, so I'll need to pay $4. Do you agree with either, both, or whatever? Well, let's do this. Let's make a little table. We have money, and we have muffins, and we know that you can get, for $3, you can get 12 muffins. That's a dozen. A dozen is 12. Which also tells me that, so Andre has $2, right? So if we turn this into a unit rate, for $1, I can get 4 muffins, right? $1 here. So if he has $2, let's multiply this by 2, so times 2. Multiply this by 2, he can get 8 muffins. So that is going to be true. That's a true statement there. Elena says she wants 16 muffins, so she needs to pay $4. Let's see if that's true. To go from 4 muffins to 16 is multiplying by 4. So 1 times 4 is $4. So that would also be true. So according to the table, it works out just fine. And our last one, number 7. A family has a monthly budget of $2,400. How much money is spent on each category? So we have 44%, 23%, 6%, 17%, and the rest is put in savings. So to solve these, we're going to do 44 divided by 100 times the total, 2,400. Here we'll do 23 divided by 100 times 2,400. Okay. Here we're going to do 6 divided by 100 times 2,400. And here 17% is 17 over 100 times the total amount to get that figured out there. And again, you can do that with a calculator, and in doing that we arrive at 1,056, 552, 144, and over here 405. If I'm reading my notes right, that could be an 8 though. I'm going to double check that real quick. I can't read my own handwriting, just like you guys always tell me. 17 divided by 100, which is 0.17, and I'll multiply that by 2,400, which is $408. Let's see, check my own work. There you go. The rest is put in savings. What's the rest? Well, we already used 44, we used 23, we used 6, and we used 17. So that's going to be a total of 10, and 10 is 20, which is 2, 4, 8, 9. What's left is 10%, because 100 minus 90 is 10% is what's left, and 10% is going to be equal to $240. Okay, which we can get that by simply moving the decimal over one spot and making it $240 like so. That's it for today. Have a great day, and we will see you next time.